Welcome. In this session, we are going to do some analytical geometry revision about grade 10 and grade 11 work. The first part will be about the formulas that you will use and find on the formula sheet. So first one is the gradient of line segment AB is y2 minus y1 over x2 minus x1. In grade 11, you learned that the angle that would make with the positive x-axis, theta, will be represented by the gradient is equal to tan of that angle, theta. Then we know the equation of a straight line, y equal to mx plus c, with m the gradient and c the y-intercept. Then the distance between 2 points, and it could also be between A and B, is square root of x2 minus x1 squared plus y2 minus y1 all squared. In grade 12, we extend that a little bit to change the d to an r and squaring this equation on both sides so that it becomes r squared is the square root of x minus a squared plus y minus b squared, because the square root sign will disappear if we square. And we will find the fixed point from, or fixed distance from that point. We'll call that distance a radius, and the point will be CAB. So if we had to plot all those points, we will find that it's the equation of a circle. So it's closely related to the distance formula. Then the midpoint between 2 points, x, a and b, is sum of the x values divided by 2 and the sum of the y values divided by 2. So it's like the average of the x values and the average of the y values. And then we will go to parallel lines, which will use the formula here above. Okay, so if we want to prove lines are parallel, we need to prove their gradients are equal. And then perpendicular lines is the gradient of the one times the gradient of the other is equal to minus 1. And we will apply that the tangent is perpendicular to the radius to the circle up above to find the equation of a tangent to a circle. Then collinear points is the gradient of between 2 points are equal to the gradient of other 2 points. So MAB equals to MAC, MAC is equal to MBC, or MAB is equal to MBC. And the angle of inclination is mentioned up above, so that theta is called the angle of inclination, and it will be between 0 and 180 degrees. And so we can find that tan of theta is equal to m. Now, if we have the gradient, we can find the angle of inclination, and we first have to work out our reference angle of a positive value of m. So if it's a negative value, we ignore the negative and find the inverse of tan. In that case, we have gradients less than 0. We will subtract our reference angle from 180 degrees. Now, one application of the angle of inclination is finding this angle up here, where we can call this one theta, alpha, and beta. And we will use the exterior angle of a triangle. So if we have the beta, which we can find from the gradient, and the alpha, which we can find from the gradient, we can there just say the beta minus the alpha gives us the theta. And now we're going to do some further applications on the Cartesian plane, looking at parallelograms and rectangles. Now, a parallelogram, to prove it's a parallelogram, we just use the midpoint of the diagonals, okay? Because the diagonals of a parallelogram bisect each other. There are other ways as well, but they normally quite long to do. Okay, then we go to this statement that a rectangle is a parallelogram with one angle equal to 90 degrees. Now that seems a bit weird because you say, well, a rectangle's got 4 angles of 90 degrees. Now imagine you make this 90 degrees. Now because those sides are parallel and co-interior angles, this will also have to be 90 degrees. And then these sides are parallel, which means that must be 90 degrees. And because of the interior angle of a rectangle or any quadrilateral is 360, this has to be 90 degrees. So we end up with a rectangle by changing one of the angles to 90 degrees. And then just a last point, straight line y equal to mx plus c, and a nice way to get the equation of a straight line is to just get the gradient and then substitute a point into the formula, and there you have it. Okay, so let's just go over this in highlights. So we start off with the formulas, which you will receive in the exam. Then we do some application with straight lines, parallel lines, perpendicular lines, collinear points, which all lie on a straight line, and then the angle that a straight line makes with the positive x-axis. Okay, and we can shift that line obviously, and the angle stays the same. And then we can go and look at how we can apply it to quadrilaterals. So I just looked at rectangles and parallelograms. We could apply it for kites as well and squares, and then finally getting equations of straight lines, which will be quite useful when we want to calculate the equation of a tangent to our circle. Thank you.